So our speaker today is Dr. Rachel Brewton. She has a bachelor's degree in environmental science from Texas A&M University Corpus Christi, a master's degree in coastal sciences from the University of Southern Mississippi, and a PhD in geosciences from Florida Atlantic University. She has expertise in water quality, harmful algal blooms, estuarine ecology, eutrophication, and marine fisheries. Her research currently focuses on seagrass loss, restoration, macroalgal blooms, estuarine food webs, and nutrient pollution. And with that, I will hand it over to Rachel. Thank you.
Thank you for the introduction. So today I'm going to talk about seagrasses and seaweeds in the Indian River Lagoon and beyond. Honor gave me a pretty thorough introduction there, so I might skip this. Just to say I'm an assistant research professor at Branch Oceanographic Institute at Florida Atlantic University. I've worked in a diverse array of fields over the course of my career, from environmental science to toxicology. Was that you or me? Okay. Okay, it's working. So as Honor said, I got my bachelor's at Texas A&M Corpus Christi, my master's at the University of Southern Mississippi, working on the Deepwater Horizon oil spill, and my PhD at FAU. I've also worked at Auburn University, Louisiana Department of Environmental Quality, Texas A&M Corpus Christi, and Florida Department of Environmental Protection. So starting way back, I want to discuss just a little bit of the evolution of seagrasses and macroalgae. So algae evolved in the late Precambrian era. So this was about 500 million years ago. And this was called the age of early life. So the evolution of algae really changed the world. And this is called the Great Oxygenation Event, or the oxygen catastrophe, I guess, depending on whose team you were on. And this led to a mass extinction of anaerobic organisms about 2.5 million years ago. And so the evolution of algae really changed the world and made it more into the world that we know, with an oxygen environment. Seagrasses actually evolved much later than macroalgae. They actually evolved from land plants that went back into the ocean. This was during the Cretaceous period. I love this cartoon here of the dinosaurs, and I imagine the seagrasses underneath of them. But however, since they evolved, they have not displaced macroalgae as the dominant marine macrophyte. Right, so just a little background on algae. Algae is plural. So if you really want to annoy a phycologist, which is a person who studies algae, you can mix that up with alga, which is singular, or algal, which is the adjective. All right. So the size varies for algae from microscopic, so phytoplankton, single cellular algae. We see a lot of these in harmful algal blooms in the Indian River Lagoon at times, to macroalgae. So this could be seaweeds that could be taller than this building, such as kelp forests. And there is a very large number of seaweeds worldwide, up to 4,500. I'm sorry. All right. And algae are very important in the world. So as I alluded to with the Great Oxygenation Event, they produce a lot of oxygen through photosynthesis. They're a very important primary producer. And so they're the base of our marine food webs. They do, though, however, lack roots, stems, and leaves, so they're different than true plants. The body of macroalgae is called a thallus, and most of them are aquatic, but some of them are terrestrial. And algal or algae have a lot of importance throughout the world. So this could be for biofuels, carbon sequestration, or nutrient removal purposes. And unfortunately, they can also form harmful algal blooms, which we sometimes call HABs. All right, I'm just going to go through a couple of macroalgae by their divisions. So we separate them by the pigment that primarily colors them. So first we have the green algae, which is in division Chlorophyta. This is one of my favorites. This is called sea lettuce. This is Ulva lactuca. You can find this in the Indian River Lagoon sometimes in low energy environments. Caulerpa prolifera is another very common green macroalgae in the Indian River Lagoon. And we'll talk about this a little later. You can see it sort of resembles seagrasses in its morphology. This is another algae that's very common on our coastal reefs here called Codium fragile, and it's called dead man's fingers. I guess kind of looks like zombie fingers. We have the mermaid span or the mermaid's teacup. And then I guess for those who partake, we have the mermaid's wine glass as well. So just showing you this to demonstrate all of the different forms that macroalgae can take. Right, so the brown algae are called division Ochrophyta. This includes sargassum natans and fluitans. These are common macroalgae that you see washing up on our beaches here, and they can cause some pretty extreme water quality issues. Our lab does study sargassum a lot. I'm not going to talk about that today, but in the future, we can certainly talk about those effects. Padina is another common brown macroalgae that we see on our coastal reefs here. All right, and then finally, just a couple red macroalgae from division Rhodophyta. This is Agardiella subulata. This is very common in the Indian River Lagoon, certain times of the year. It's very interesting where if you pick it up and kind of crush it, it smells like onions. So you always know if you have Agardiella that it stinks like onions. This is Hypnea muciformis, another very common IRL species. It has these little curlicues at the end, so it makes it very fun and easy to identify. And then Hypnea spinella. So those of you who fish in the lagoon, such as some of our colleagues here, might recognize Hypnea spinella if you're ever out using a cast net or fishing and this red, very fine algae gets covered all over your lines. That's probably Hypnea spinella. And at certain times of the year, its biomass in the lagoon is pretty impressive. All right, so clearly I like macroalgae more than the average person. Why do we study this? As I said, they're very important benthic primary producers, so they represent the base of that marine food web. Macroalgae are interesting because they integrate nutrients over time. And so if you have a plant that's sitting in one spot, it's taking up nutrients from that location, it can tell us a lot about what's happening in that location. And a lot of these nutrients that it's taking up are reactive or inorganic nutrients, and they can drive harmful algal blooms. And so this together, we can analyze the tissue and help us understand nutrient sources that are driving these changes that we're seeing in our marine environment. And so in that sense, we can use them as bioindicators of eutrophication or of change in the lagoon. And this makes them represent a piece of ecosystem-based management for seagrass ecosystems and coral reefs. So harmful algal blooms, which I know a lot of you are probably familiar with, can be phytoplankton or macroalgal based. They can cause harm through direct toxicity. So the algae makes a poison or a toxin that can kill an organism. Alternatively, they can smother habitats or organisms through their excessive biomass. And the impacts of harmful algal blooms can include mass mortalities of fishes and shellfish, deaths of marine mammals and seabirds, alteration of marine ecosystems through the formation of things like dead zones where there's no oxygen in the water, and they can also cause human illness and death. And macroalgae are very opportunistic, so they're usually the first responders to pollution in the marine environment. So this problem is not unique. This map shows the United States, and the different colors represent the different types of algae, so red, green, brown, and blue-green. And basically what you can see is wherever there's water, we have harmful algal blooms. Florida has a lot. So because we have so much water and so many people, we probably have some of the most problems with this issue. Just to show what some of these very high biomass harmful algal blooms look like, I wanted to show a few pictures of ulva macroalgal blooms that disrupted the 2008 Olympics. And just to show how, I know a lot of us are familiar with phytoplankton harmful algal blooms, just to show what these macroalgal blooms can look like in some locations. What we've seen here that's more similar to this would be when we have the heavy impact of sargassum biomass coming ashore. All right, so what is the difference between macroalgae and seagrass? I mentioned earlier how they evolved separately, but they can look similar at times. One big difference is that algae can take up nutrients from the water column a little more easily than seagrass, which primarily takes up its nutrients through the roots, rhizomes. However, it can also take up some from the water column as well. Right, so seagrasses are flowering plants. Like I said, they were actually land plants that went back into the ocean. Globally, we have about 60 species. They have long, narrow leaves, rhizomes that are root-like structures, and ideally they create vast meadows that cover sediment, stabilizing it, creating habitat for fishes and crustaceans. And so in many locations, they are deemed to be essential habitat, so critical habitat that organisms need. They are carbon sinks, so they can take carbon out of the atmosphere, helping us mitigate climate change. Unfortunately, they are very sensitive to degradation. In the lagoon, we have 7 species, so just to remind you of those pretty quickly, Haliduli rhytii is probably the most common species we have in the lagoon. So a lot of our restoration efforts are focusing on this species. It's one of the hardier species, and it can tolerate degraded conditions somewhat better than others. Syringodium filiforme is manatee grass. We have Halophila. We have a few species of Halophila stargrass. These are our smaller seagrasses that you see on the bottom. Halophila decipiens, which is paddlegrass. And we did have Halophila johnsonii, which was considered to be endemic to the Indian River Lagoon. However, genetic studies recently revealed this is not a unique species to the Indian River Lagoon, but it's actually a species that is commonly found in another location. And so it was on the protected list of NOAA of endangered species. It was recently removed. So things are ever evolving with seagrasses in the Indian River Lagoon. We also have Rupia and Thalassia. Thalassia is probably our most sensitive seagrass. This historically was not found north of Sebastian Inlet, but now I think you primarily will only find it near Jupiter, where the water clarity is much better. So seagrasses bring with them a high economic value. So I said they provide nursery habitat for a number of important fishery species. Their commercial value is estimated at 110 billion. Recreational value is even higher, 900 million. And it's estimated that an acre of seagrass is worth about $20,000. And that was in 2000, so with inflation, it's probably way more than that today. And so totally, it's worth about $44 billion statewide a year. So a threat to seagrasses in the Indian River Lagoon is something that we call cultural eutrophication. And so an easy way to talk about this is a global issue, but as we see populations increase, we see the nutrients in the water also increase. And that happens pretty much anywhere you have people, the water adjacent to where they live tends to become degraded. This is so prevalent worldwide that humans were actually added to the water cycle. So we're now an official part of the water cycle. And with climate change, this issue will continue to worsen because as we see rainfall increase, the nutrients that wash into our water bodies also will continue to increase. And in the Indian River Lagoon, this is a pretty critical issue to address. This figure shows chlorophyll A. So chlorophyll A is an indicator of the amount of phytoplankton in the water column. So it's a microalgae. And as the human population has increased, we've seen the chlorophyll A also increase. So just driving home that point, the more people we have, the more nutrients we have, and the more phytoplankton we have. Unfortunately, increasing algae in the water can affect seagrasses in many negative ways. They can cause anoxia or fragmentation, so a lack of oxygen. They can basically smother a seagrass bed and cause it to die. Additionally, algae can grow on the blades of seagrass, making it where the seagrass can't get sunlight and photosynthesize. It also dies. And then finally, planktonic algae in the water column can stop sunlight from reaching the seagrass. So there are a number of different ways that increased production of algae is negatively affecting our seagrasses. So we're all familiar, I think, maybe with the Indian River Lagoon. It's an estuary of national significance. It's also a very important biogeographic transition zone between tropical and subtropical. It's a very shallow system throughout. And it's highly urbanized, especially in Brevard County. A large proportion of the shoreline is hardened and urbanized and has been for a long time. Again, particularly in Brevard County, the flow of water throughout the IRL is very restricted. There are a number of causeways that interrupt the flow of water, which means that when things get in the water, they have a long residence time. So rainfall that washes into the basin here may have a residence time of 200 or more days in that area. And we have seen land use changes throughout the lagoon. Mostly this is increasing urban and decreasing agricultural development. So there are a number of issues facing the lagoon, which include nutrient and microbial pollution, discharges of fresh water from urban areas or from other water bodies, seeing decreases in fisheries species, increases in wildlife diseases and mortalities, and losses of seagrass throughout the system, as well as harmful algal blooms. So one of the issues that we've been dealing with in the Indian River Lagoon are the effects of septic systems on the water bodies. We have over 300,000 septic systems along the Indian River Lagoon. Within Brevard County, there are about 53,000. And the thing about septic systems is that they're supposed to leak. You know, we always hear about leaky septic systems, but the design is that the waste should percolate out of the septic system through dry soil, which treats the waste. However, in Florida, we have these high water tables. And so the ground is saturated with water. And so as the effluent leaks out of the septic system, it can mix directly with the groundwater, which can then contaminate the adjacent surface water. So, you know, a huge issue with these is the density that we see them in and the proximity to water. So when they're close to water bodies and high densities, they're more of a problem than if you have a septic system and you live out in the country and there's no surface water near you. Septic systems contribute about 9 pounds per year of nitrogen per person. And a recent study found that as little as 1% of human waste in a surface water body from wastewater promotes the presence of Vibrio prolifera, which you often hear called flesh-eating bacteria. You know, it's really nasty stuff that you don't want in the surface water. In the IRL, we have about 50% in most counties hooked up to septic systems versus hooked up to centralized sewer, and we're a little higher than the national average. A lot of the counties have been putting in a ton of work to decrease the number of septic systems along the lagoon, connect people to centralized sewer or septic systems that can actually treat the wastewater on site. So this will continue to change, and this problem is being improved as we speak, which is a good thing to note. So this is a concern because, as I've mentioned a few times, as the nutrient load in water increases, we see changes in our primary producers. And this figure is a favorite of mine. It shows the relative biomass of different primary producers, so phytoplankton, seagrasses, and macroalgae, and how they change theoretically with increasing nutrient loads. Of course, there are other things that can affect these, such as grazers, but we're just talking about nutrients for this diagram. And so basically you can see at low nutrient levels, we tend to have more seagrasses and less phytoplankton. And as this nutrient load increases, we'll initially get a bump of macroalgae, but then phytoplankton tends to kind of dominate and everything else gets shaded out. And so what we want to do is bring the Indian River Lagoon back towards the low nutrient and high light environment. And so this cartoon sort of illustrates what I was just saying a little bit better. This top cartoon here shows a low nutrient environment. They have a healthy coastal filter. So the stormwater runoff has marsh and mangroves to percolate through before it reaches the water body. So they have very clear water, healthy seagrasses, happy fish. As that nutrient load begins to increase, we start to develop and lose our coastal filter. So the stormwater isn't being treated before it reaches the lagoon. Phytoplankton starts to become denser. And then we get to the final cartoon. We have very high nutrient load, no coastal filter left. The phytoplankton is very dense, and what this does is it means that light can't reach the bottom and the seagrasses can't grow. So essentially, as nutrients increase, the organic matter in the system increases, and we see what we call trophic shifts. So these shifts from seagrass dominated to macroalgal. And this has been known for a long time. In 2000, the National Research Council declared that the fundamental driving force changing systems was the accumulation of nitrogen and phosphorus in freshwater as it goes to the ocean. So again, we've seen seagrasses kind of be taken over by macroalgae, and then some of these very intense phytoplankton blooms that have occurred. And one effect of this, as I mentioned, is a decrease in light availability. Seagrasses need light to photosynthesize and grow. What this figure shows is light attenuation. And so what we actually want is a lower value. So we want less light to be attenuated so that more is making it to the seagrasses. And so this just shows 2015, during the wet season, with very high light attenuation. So that means there's not enough light making it to the seagrasses. But we rely on our dry seasons for seagrasses to recover and grow. That's usually when we have the clearest water. In 2015, they were barely low enough. They were close to what seagrasses want to thrive. And so this is a big area that people are trying to improve in the Indian River Lagoon, clearing up the water so that our seagrasses can really recover and come back. Many of you may know we've had a manatee unusual mortality event in the Indian River Lagoon. It was about 450 deaths in 2021, 2022. There were about 580 the previous year. And this was attributed to a lack of seagrasses that resulted in malnutrition and starving of the manatees. And one major finding of this unusual mortality event was that a lot of the deceased manatees were eating macroalgae. And macroalgae can contain toxins, and it's also just not what they eat. So, I mean, as people, we eat certain things regularly. When you eat something much different, it can upset your stomach. And what happened with the manatees is that they were eating something they couldn't digest very well. It led to them having clostridial infections. And so there are cascading effects of the changes of losing the seagrass in the Indian River Lagoon that we're trying to mitigate by improving conditions. So another issue is connectivity of habitats. So as I've said, seagrass provides very important habitat in the Indian River Lagoon. As we start to lose it, this habitat becomes fragmented. And so populations are not able to mix as well as they could before. And when we have very extreme seagrass loss, this can affect their ability to sustain themselves. And as you can imagine, as this habitat becomes fragmented or gets lost, this can affect food webs because we can lose those connections between predator and prey throughout the system. But other things can provide habitat in the Indian River Lagoon besides seagrass. There have been in Brevard County large-scale blooms of Caulerpa prolifera, which is a green macroalgae. This was my first experience with Caulerpa in the IRL, March of 2020. We went out to do some sampling, and it looked like the bottom was completely covered in seagrass. I'd never seen anything like it in the lagoon, unfortunately, and it turned out to be Caulerpa prolifera. And this is quite zoomed out. We actually drove our boat to try to find the end of it, and we couldn't. It was just miles and miles of this Caulerpa covering everything. And so this shows a couple other locations. The dark is Caulerpa. It was very expansive, and it still is in many locations. And so what we really wanted to know was, in the absence of seagrass that we were experiencing, is this Caulerpa providing habitat, kind of like interim habitat for those organisms? You can see there's a stingray. Maybe I just ruined the surprise. There he is. Stingray hanging out up there. And we did observe a number of fish, large fish, around these habitats. And so we wanted to take a look at that a little more. So here's a few more details on Caulerpa. It's a bloom former. So as you can see from those satellite images, it can just expand and really take over open spaces. What is good about it, similar to seagrasses, it does have root-like structures, so it can help stabilize the sediment. And so it could be helping clear up the water, maybe making conditions better for seagrasses to improve. It also has lower light requirements than seagrasses, so they really like a lot of light. Caulerpa can thrive when things are a little more murky. And so that's why they're able to survive in places of the lagoon right now where seagrasses are not. They're also nitrophilic, so unlike seagrasses, they really like a high nitrogen environment. Unfortunately, they do produce a toxin, which is called caulerpanine, which prohibits a lot of grazers from eating it. And this figure, I realized there's a companion figure to this that shows the seagrass over time. It might have been nice to show you guys that first, but that kind of goes the opposite way. So this is showing cover of Caulerpa prolifera over time. We have the super bloom there when pretty much the seagrasses crashed, and so did Caulerpa. But since then, what we've seen, while the seagrasses are still trying to come back, we've seen the Caulerpa really come in and expand. And this data is courtesy of St. Johns River Water Management District. They've been doing wonderful seagrass and Caulerpa monitoring for over 20 years, and they're really doing a great service to the lagoon with it. And so I'm going to show a little bit of data from just two different events. March of 2020, when I first found that giant Caulerpa patch, the water clarity was the best I've ever seen in Brevard County. There was about 100% Caulerpa cover on the bottom. And then we plan to go back out many more times, but COVID actually shut down our work for a while. So once we were able to get back out, it was November of 2020. There was, one of my colleagues said, oh, there's a bloom happening. I was not prepared. The water was electric green up here. And when you stepped off the boat ladder, you couldn't see your feet on the first rung. It was the worst phytoplankton bloom I think I've seen. That was in November of 2020. And as you might imagine, at the same sites where we had a lot of Caulerpa, there was nothing living on the bottom. And so I'm not going to go through most of this for the sake of time. What I really want to point out is the first graph, which shows dissolved inorganic nitrogen. So this is ammonium, nitrate, nitrite. In March, when we had that Caulerpa bloom and the water was clear, we had very low inorganic nitrogen in the water. When we came back in November, there had been a lot of rainfall. The inorganic nitrogen load was significantly higher. That's 20 micromolar. That is, that's approaching effluent, like approaching human waste. That is a very high nitrogen concentration. And so this is just demonstrating again, when you have such high reactive nitrogen concentrations, something is going to grow, and it probably isn't going to be what you want to have growing in the water. So what we did is we went out in the Caulerpa and then in that really nasty green toxic looking water. And we got in and we collected the organisms on the bottom using a net. And the March sampling with the Caulerpa is shown in blue, and the November sampling is shown in orange. And we see very different stories between these two events. So in March, we saw a lot of organisms that you would normally see in seagrass beds, different snails, small fishes, shrimps. However, when that was gone, we just had the bare dirt bottom with the phytoplankton bloom. Primarily what we had were things that aren't associated with habitat, such as ctenophores, like the little comb jellies that you see floating around, mysid shrimp. There were a few overlaps, but on the whole, it was a completely different community in the same location between those two events. And so just demonstrating how important it is for us to restore that benthic habitat for our fisheries and the health of the lagoon. So just to go over a couple of the findings of our recent research, we've seen consistently that there is nitrogen enrichment throughout the Indian River Lagoon, and we've observed phase shifts that have happened in the benthic primary producers because of this. So the switch from seagrasses to macroalgae to bare bottom. And in some areas of the lagoon, it really does appear to be hyper-eutrophic. So this would be this bright green picture on the top. However, we do see that these blooms of Caulerpa prolifera are creating a habitat that is species rich and maybe is helping us like a Band-Aid to get to the point where seagrasses can recover. And so there are quite a few new studies happening. I know FIT has a couple started to help us understand, is this a good thing, or is this like a really big harmful algal bloom that's going to actually make things worse over time? And I think you can see when we alter primary production, there's cascading effects, that range from shifting species living there to the deaths of things like manatees and seabirds. And so a big question that I know a lot of the resources managers have is what do they need to do in the lagoon to manage for seagrass recovery? And, the conclusions are broadly reducing nutrient input and trying to make the water clarity better so that seagrasses can come back. Uh-oh, I lost it again. And again, the question of if these blooms are supporting seagrasses coming back or inhibiting it. We don't know that just yet. Right. So sometimes I feel like when I'm giving these presentations, it's very depressing. So let's try to, what can we do to make things better? None of these problems are something that someone personally created. And unfortunately, that means that we can't personally fix them. Just doing something yourself is not going to make the Indian River Lagoon better. But lobbying your civic leaders is something that is very powerful that all of us can do to help promote positive changes in the management of the Indian River Lagoon. So a big push has been septic to sewer conversions. Not just septic to sewer, we really need to improve our wastewater treatment systems in this area. They can remove up to 99% of nitrogen in some systems with advanced wastewater treatment. So as we invest in this improved infrastructure, we can make the water better and give the Indian River Lagoon what it needs. A huge issue along the Indian River Lagoon is improving stormwater management. We've seen it just in the last few weeks, these incredible rain events where everything just washes directly into the lagoon. We need improved management of stormwater, where there's a place that stormwater can run into and be treated before it goes into the lagoon. And just improve management of water overall. So a big thing to do is to get involved at a civic level, vote, tell your policymakers what you care about, including all of these things, living shorelines. On a personal note, you can always pick up after your pets and have Florida-friendly yards. So you can do things personally, but the things that are really going to make the biggest changes will be what we can do as a community. Another thing that we're doing as a community is, I think a lot of you have probably heard, there's a number of partner seagrass nurseries that have been identified along the Indian River Lagoon. So this includes the Marine Discovery Center in New Smyrna, the Brevard Zoo, Sea and Shoreline, Harbor Branch, and Florida Oceanographic Society. So we all at our different institutions have seagrass nurseries that are ramping up our production to help with restoration efforts. At Harbor Branch, we have a system that's two ways. We have a land-based system. Some of it is recirculating water and some of it actually uses flow through Indian River Lagoon water. We currently have 5 tanks that are all about 10 feet long with seagrass growing. We have a huge development in process where we're going to be adding almost 24 new tanks. So by next year, we should have about 30 tanks where we'll be growing seagrass stock to help in restoration efforts throughout the Indian River Lagoon. Additionally, besides those tanks, we're going to have an experimental greenhouse that will be dedicated to understanding how different conditions affect seagrass. So we can test different water clarities, different temperatures, and try to figure out what stocks are hardiest, and different methods that might be employed to make restoration efforts more successful. So this is our cartoon of how our nursery will come along. This QR code goes to what will say coming soon. There will be a website in process. So we're going to be doing some water quality improvements. We really want to turn the nursery that we're building into a place where you can come and learn about seagrasses. So we'll be trying to have informational signage. We'll be doing some additional fundraising to try and put in a lab space, covered pavilion work area. So it'll be a place that we can bring in volunteers and students and they can safely work and learn with us. A lot of people helped with this research. We have a ton of volunteers at Harbor Branch. If you're interested in that, we have some information up front. St. John's River Water Management District, again, does so many wonderful things for the Indian River Lagoon. Dr. Dennis Hanasak has led a lot of this work over the last few years, so acknowledge him here. And a number of collaborators. For the nursery, our funding sources include the IRL NEP program, FWC, Next Era Energy Foundation, and the Harbor Branch Oceanographic Institute Foundation, who have all very generously invested in us trying to make the future of the lagoon a happier story. So there are a number of ways you can become engaged at Harbor Branch. You can join our mailing list or follow us on social media. We have really interesting boat tours that you can take. They have an ROV that they put in the water where you can see what's happening under the lagoon in real time. And then you can join us for events. So there's another QR code if you want to scan that to learn more. And I'll be happy to take any questions. QR codes to our lab's website and Instagram. And feel free to also reach out to me with any questions if you think of them later. Thank you.
Awesome. So if you do have questions, go ahead and write them down on the note card, and then raise your hand and I'll come to collect them from you. And then if you have questions on Zoom, go ahead and pop them in the Q&A. I'm going to start with a question, an email question that we got before the presentation. Is it true that when lawns get cut and the cut grass gets blown into the lagoon, the chemicals, such as fertilizers and stuff like that, promote the growth of algae?
Yeah, there's definitely some truth to that. So anything that ends up in the water has an effect. So if you are working your lawn and you have a number of pesticides, herbicides, fertilizer, that can run off into the lagoon. University of Florida has conducted a lot of studies on the timing of fertilizers. I think they're finishing up a big one this year because well, this could be an hour-long discussion on that. But when to fertilize is really important, and what you do on your lawns can affect the lagoon. That's a concise answer, but for more information, I would look to the University of Florida IFAS.
This might not be something you know, have there been any negative effects to the sea turtles that were doing?
Yeah, so that would be a good question to ask Dr. Page when she comes back. But certainly, with any sea turtle whose primary dietary preference is seagrass is not thriving in the lagoon right now. But they are much more mobile than a lot of the other organisms. They can go other places. So I think it's safe to say they're being impacted. I know there are a lot of issues of how water quality in general has affected the sea turtle populations, their health in the lagoon. And Dr. Page, when she comes to plug, I don't know when she'll come back, she has studied that and can tell you all about how water quality is impacting the organisms.
Let's see, it looks like you mentioned that Caulerpa has a toxin that a lot of species can't eat. Can manatees eat Caulerpa?
No, so in the slide that I showed that had the stomach contents of manatees, I guess I didn't really point that out. The stomach contents were filled with Caulerpa, it looks like. So it is not. There is a sea slug who is specialized to feed on Caulerpa, who can like attach to it and suck the insides out, and it then uses the toxin to protect itself. But other than that, there's not many things that really want to eat Caulerpa.
Are there
Could you speak up just a little bit?
Are there places where they have successfully updated wastewater treatment and nutrient removal?
There are, and I actually had in some slides, but I wasn't sure I would have time. The success story that is pointed to a lot is Tampa Bay. In the 70s, the development increased a lot. In the early 80s, they had some issues actually with macroalgal blooms that really, I think the smell of the decomposing macroalgae all along Tampa Bay shoreline prompted a lot of action because nobody wanted to be there. And so they invested a lot in wastewater infrastructure, stormwater infrastructure, and they've really improved their water quality. They brought back their seagrasses to historic levels. And so they're often pointed to as like the success story. Also, Chesapeake Bay has had a lot of success recently with seagrass recovery. That said, Tampa Bay still has to address issues as they evolve. And so, we need to catch up with our water quality and our stormwater investments. And we'll just, living along the water bodies, you just kind of have to stay vigilant and adapt to whatever the next issue will be. But it can be done, and hopefully we will have that success story in a few years.
Where is Harbor Branch and is the Seagrass Nursery on site?
So Harbor Branch is located in Fort Pierce. So we're about 55 minutes south of here. It is really, it feels like it's located between Vero Beach and Fort Pierce off of US 1. We do have a visitor center that's open Tuesday to Saturday, and the nursery is located on site. It's currently not open to the public. If you take a tour, they do drive by it. And as we make these changes that I showed, we will make it more visitor friendly and hopefully be a bigger stop on the tour in the next year or two. So come see us.
Is diverting stormwater to St. James River a viable possibility, or would it increase negatively impact the IRL salinity and other water quality?
Yeah, I can't honestly speak specifically to that because I'm not as familiar with that inflow, but I would think wherever you put the stormwater is going to be impacted negatively. So probably one of the best things is to treat the stormwater in the location it's in. So I know in Brevard County, there's been installation of some baffle boxes. So rather than just a traditional system where it goes into a rain culvert and then is put directly into the lagoon, you can actually put in some infrastructure where the water can settle and be treated and then put to the lagoon. So that might be a better option and also help keep the salinity where it should be.
Has there been success, I guess, does muck removal or the clam bed projects or oyster restoration, do any of those things help with seagrass recovery?
Yeah, I would think, and it's all kind of tricky, what to try to do first. I think there is a lot of agreement for seagrass that we can't conduct widespread restoration until we've seen some water quality improvements. And so the nurseries are being put into place and developed with the hope, the anticipation that a lot of the infrastructure investments being made will improve water quality to where we can be successful. And so I think it's a similar story for the oysters, the clams, and the seagrass. Certainly having healthy clam and oyster populations would clear up the water and make it easier for seagrasses to recover. But if the water is full of phytoplankton that are toxic to them or not something that they want to eat, then they won't grow. So it's all related. But I think all of the efforts are good. And certainly the seagrasses aren't going to thrive in muck. So if the removal improves the sediment to be more conducive to seagrass recovery, then I would definitely think it would help.
Are Harbor Branch and their partner institutions doing seagrass planting? And is there an option for homeowners to opt in to have a research site on their shoreline?
Yeah, so all of the different partners are doing different things with their nurseries and with their plantings, but it is all related to restoration. I would think, especially up here, the Brevard Zoo Seagrass Nursery would be the best contact for that sort of thing. I don't know about seagrass plantings, but they do have, and these aren't my programs, so I can't speak perfectly to them, but they do have opportunities for things like putting out oyster gardens. And so right now for those things, I would refer you to them. And as we develop our nursery, we may have some opportunities at Harbor Branch in the future as well.
Are the healthy areas of seagrass within reasonable reach of warm water refuge for manatees heading into winter?
That's a tough one. I don't think I have the answer to that off the top of my head. The St. John's River Water Management people who are serving the seagrass all the time would probably be able to speak best to that. I don't know. I do know that this has been one of the better years that we've had for a while for seagrass. And so I don't think, and if anyone knows differently, please feel free to correct me. I don't think that they did the manatee feeding last winter. And so if this year is better for seagrass, I would think that they will probably not have to do it this year.
Can you address macroalgae uprooting and displacement during storm events and subsequent decomposition?
Yeah, so with Caulerpa, I think that is a big issue and concern because even without storm events, it senesces at some point during the year, so it will quit growing, and we've observed large balls of it detached. I mean, maybe not that. like 4 feet tall, maybe, kind of tumbling across the lagoon. And that will, come up on a shoreline, lay on top of a seagrass bed, maybe a restoration site, and decompose. And so that is something that I know resource managers in Brevard are trying to figure out what to do about, because that is an issue. It is a more ephemeral habitat than seagrasses, so it's to be expected as part of the life cycle. And so there have been discussions of things like, should Caulerpa be harvested at certain times of the year? So that's a hard question to answer. But that is an issue, I think, is all I would say.
Is there any difference in the harm between a fertilizer versus an herbicide? Is one of them worse than the other?
Those are, very different things. So the fertilizer, if you are, let's say if you're incorrectly applying fertilizer and your lawn is adjacent to the lagoon, you could be providing nutrients for the growth of harmful algal phytoplankton. If you're similarly applying herbicides, there could be sublethal or lethal effects to things like seagrasses because of that. It could be that there is an inhibition to seagrass recovery from loads of herbicides. It's certainly not helping. So the best thing to do would be to be very thoughtful in your lawn care if you live adjacent to the lagoon.
So is there a reason that we might be seeing an improvement in water clarity, but sort of a lag in seagrass recovery where it's maybe not coming back as fast as we might be expecting?
Yeah, there's a lot of reasons that you could talk. So one issue, a major issue in the lagoon that has been noted is a lack of seed stock for seagrasses. So seagrasses can reproduce vegetatively or sexually. So if there's not seagrass there to spread out and grow vegetatively, it could grow from seeds. However, there's not much seed stock in the lagoon right now because it's been low for so long. So that is one major issue to overcome. Aside from that, I would say that's probably one of the biggest. And that kind of goes hand in hand with another thing that has been identified in restoration, which is we have a lot of hungry grazers out there. So when you do restore seagrass, they're going to come eat it. And so those are two of the major hurdles and probably reasons why even when we have better water clarity, it's not just popping up. It will, take some effort. It could be growing, but then it's being eaten, very quickly or at an unsustainable rate.
Do the higher water levels that we're seeing right now have an impact, positive or negative, on the seagrass?
Yeah, so generally it would be a negative impact when you have higher water levels, because the sunlight has to make it through the water column to the seagrasses. So if the water is deeper, then that the attenuation by the water column will be greater. And so less sunlight should make it to the seagrasses when you have deeper water, unless it's very clear, and then it might not be an issue.
Okay, so I had a question about tipping points between kind of going to the algae, between when you have algae doing good things with bringing nutrients out of the water, storing it in their bodies and adding to clarity, to when you turn into the harmful algae. Do we have an idea of what those tipping points are?
Like what level of biomass, or I think it's probably very circumstantial. That's a really hard, and I think that is a very good topic to study and understand. I certainly don't have the answer today, but at some level, yeah, there's gotta be a switch between doing something good and not. The Caulerpa in the lagoon is a very interesting thing because the blooms, I mean, like I said, we got in our boat and we thought we'll drive to where it ends, and we could never find the end. It just went on and on and on. I had to turn around eventually, but while it's there, it's stabilizing the sediment, helping improve water quality, taking up nutrients. Unfortunately, we haven't had a study where we've been able to go out and really study those details. What starts to happen as the growing season slows down? Do the nutrients load? Does it increase the nutrient loads as it starts to die? Is seagrass able to come in there? So there's a lot of unknowns with that. I think it's sort of an experiment that we're all watching, a natural experiment right now.
What do you see as the biggest hurdle to implementing septic to sewer projects on the lagoon?
I think that there is, since I've been at Harbor Branch for 8 years, and I feel like I've seen the perception of policymakers and residents change a lot in that time. I think people are interested in doing it. Hurdles can be different. So for example, a personal hurdle could be people can't afford it. There are programs that can help with funding, grant programs to help match people getting set up. Other hurdles have been, you're not in a neighborhood that can be hooked up. There are, though, now a number of on-site systems where even if you can't get hooked up, you can put one of these systems in. They cost about the same as hooking up or less. And then you can have on-site treatment of your waste. So I think a lot of the hurdles that have been there are being overcome, but it takes a long time to put in infrastructure. And that's why when a lot of places in Florida were built, there's some colorful development that has happened, throughout Florida's history where people want to develop cheaply and fast and get people here and make a lot of money setting it up. I'm not saying that's the case everywhere. There's probably some very good developers too, but people wanted to build quickly. And so that's why they went with septic systems a lot of times. And so that's why hooking up to sewer is such a chore, because it's not quick and easy. You have to put in the infrastructure. It takes some time. So that's a huge hurdle. But I think it's a really important thing that has to be done, as well as improving wastewater treatment at aging wastewater treatment facilities. That is equally important in many locations.
Okay, I'm gonna squeeze one last question in. A company is selling a product for osteoporosis, and they say the calcium in it is from algae. Would there be any benefit from this, or would there be toxins concentrated in the algae?
That is a good question. It probably depends on what kind of algae it is, and I can't say that. For any supplement, I would just say to get something that is approved by the FDA, something made in the United States where you can trace the sources, because people, there's sometimes not enough oversight over things like that. So, can you tell me the original question again? I think I got off topic.
So would there be any benefit, or would there be toxins concentrated?
Yeah, I think it's very unlikely they're using like a harmful algae to make the supplement. So again, just assuming that you got it from a reputable source. There are a lot of algae that can have good benefits. They could have high protein or calcium. So certainly, assuming it was grown correctly, yes, I would say that could be a viable option, but I'm not that kind of doctor. So maybe ask your doctor about it.
Okay, thank you so much, Rachel.
Thank you.